My name is Charlie Ismert with Schier Products. This is Luke Ismert with Schier Products, and we're here today to talk about the grease interceptor industry at large and the fog abatement dynamic. That basically means the state of the industry as we see it, what's going on as far as current designs that are out there, materials, some of the standards, and then how do these grease interceptors work. A lot of you might have seen, as far as grease interceptor designs that are out there right now, that there's a momentum going towards larger exterior grease interceptors, going away from the typical point of use grease interceptors, which are a less tested sort of slate of products. So they're going away from typical performance-based indoor smaller designs to more design standard-based grease interceptor exterior designs. So we kind of wanted to review that. That's sort of the introduction. So the first part is, why is grease interceptor, or why are grease interceptors so important? Why is grease pre-treatment so important? The first key to that is grease in general is one of the largest contributors to sanitary sewer overflows, commonly known as SSOs, which are a public health issue. They're discouraged by the EPA and mandated that municipal sewers stay in compliance so that there are no overflows. One of the biggest causes of pipe blockages that are out there are fog, or fats, oils, and greases that are in the lines. As you can see, we've got a few photos here of some grease offenders, some restaurants where grease has been introduced into the sanitary sewer system, and you can understand by looking at these photos how grease would cause some backups in the line.
Just as a kind of a quick aside, explaining this first picture here, you're looking at a typical manhole from the top down, and what you see coming down the top here, what you're seeing is a sewer lateral coming into the sewer main, and the lateral has got congealed grease all around it there as it comes into the main. A lot of municipalities, typically the smaller municipalities, are going to moving towards cammering of lines, of sewer lines, because it provides a smoking gun, supposedly, to the grease offender restaurants. So when you've got congealed fog coming right out of your lateral going to the sewer main, it's evidence that you have a grease problem. So that was just a quick explanation on what that is.
The other reason that we need grease interceptors is just strictly for the wastewater treatment plants. They want as much grease out of the sewers as possible before they start treating the wastewater. To do one of two things, basically: to introduce the wastewater back into the environment, rivers, streams, and lakes, when it's deemed clean enough to be introduced, and then for the other reason, to render it back into potable water. So when they've got fog-laden water coming into the pre-treatment plants, it bogs down their process. It takes a lot longer. It's a much more inefficient process for them. So what we're seeing anymore a lot of days is the requirements for the exact way a grease interceptor needs to be built, the standards that it needs to meet, that it's being mandated by the pre-treatment authority versus the plumbing authority that it's typically been mandated by in the past. So, but they're usually in cahoots with each other as far as what the pre-treatment is requiring, and then plumbing is doing the basic checkup on that to make sure that it was installed correctly. The final sort of common sense impact is the environmental impact. When you're introducing grease-laden wastewater into the environment, it can introduce basically an overgrowth of algae, vegetation, fish life, fish population as well. So just the basic environmental impact by introducing extra grease into the environment. The way that we see it, there's two basic approaches to standards that are out there. There are the flow rate based standards that are out there. The ASME standard, the PDI standard, and the CSA standard are performance based standards. What that means is they give a minimum requirement for grease storage efficiency and capacity, and they've got a range of products that are sized by GPM, and for each GPM there's an equivalent grease storage capacity. The difference between that is that with the larger units, they have design standards, and those aren't performance-based standards. Those are strictly volume-based standards, which means that there's an assumed performance with the larger grease interceptors. The ASME standard, they've got a family of series. So they've got ASME A112.14.3, which is for the typical passive grease interceptors. They have .4, which is for the bacteriological, I believe, grease interceptors, and then they have 0.6, which is for the grease removal devices. Basically, it's still a passive grease interceptor, but it's got a skimmer and a heating coil on the top, and everything goes into a separate compartment. .6 is bacteriological. Okay, so .6 is bacteriological. .4 is the grease removal devices. But today we're concentrating, for the most part, on the passive grease interceptors, comparing the smaller footprint designs to the larger footprint designs. So the ASME standard family is a consensus standard. That means it's an open process. It's written by engineers, inspectors, plumbers, manufacturers, everyone in the know. PDI is a proprietary standard, which means that it's written by a collection of manufacturers, so it's a closed process. The CSA standard is basically a reflection of the ASME standard. So in other words, it says they have their own standard number for it, but it says see also ASME A112.14.3. So it's basically the same thing there. Some of the main differences are, first of all, they all cover the same range of flow rates or GPM, the PDI standard and the ASME standard, and they go from 4 GPM up to 100 GPM. But the PDI standard has been around much longer than the ASME standard, and they're virtually the same standard. But one of the key differences that we found with the ASME standard as an improvement over the PDI standard is that they allow for a non-external flow control method. So if we're familiar with external flow control, it's the housing that we'll get into it a little bit more, but it's the housing in the inlet line that precedes the grease interceptor, and that's in place to meter or regulate flow so that none of the effluent is sweeping through the grease interceptor too quickly. So the PDI standard has been based on external flow control since its inception. The ASME standard allows for external flow control like the PDI standard does, but it also allows for non-external, meaning if there's a better method to controlling flow, you're allowed to do that and test your products to that standard. So the way we see it, the ASME standard is a superior standard to the PDI standard because it's a consensus standard and it makes more allowances for innovation on the market as far as different products that are out there. The second part to sort of the review of the national standards that are out there are the volume-based standards, and these are the for the larger exterior products. So IAPMO has the Z1001 standard. I believe that starts, where's that, the 300 gallon range?
300 gallon minimum.
Okay.
Yeah, basically it describes the, real quick, it describes, like all these do, more the design of the shell of the interceptor and does not get into efficiency criteria.
And then the same thing with the ASTM standard that's under development. It's based on design criteria. UPC Section H, same thing. The problem with that, as we see it, is that these are not performance-based standards. There's an assumed efficiency there, and typically with a lot of municipalities we're seeing an entry point of about 1,000 gallons as far as a grease interceptor, a product that needs to get installed outside. So these are very unregulated, and when you have a standard that only covers the criteria of design, you're going to have a minimalist approach from as many manufacturers or fabricators as possible to meet the standard. So when you're not meeting performance, it sort of opens the floodgates to have inferior products on the market.